Hello everyone. Once again, I'm going to be doing a malware traffic analysis exercise with you. Actually, it's a little bit of a lie. I'm not going to do the exercise. I'm going to have my pre-configured agent do it, but talk you through my setup and how I'm probably not going to do any more PCAP analysis because it's just something AI is so good at doing, and we'll demonstrate that here today. So this is the most recent exercise from malwaretrafficanalysis.net. I've been doing these on and off for years, and I'm just going to demo my AI. I'm using Pi as the harness. And what I'm actually going to do is I'm not going to type a thing. I'm just going to ask it, the AI, please download this exercise, then load your PCAP analysis tool to analyze the exercise, and then open your final report and the directory for me once complete. And I'll give it the URL, and away it goes. So we can watch it. It's going to fetch the site. It's going to load the skill. It's coming up with a list of instructions. It's got the files. It's hit the password issue. So you need a password to open the files. So it's found the password image. It's reading the image to get the password. I imagine the author of PCAP analysis deliberately put it in an image to make it harder for AIs, but these days it doesn't stop them. And there we go, it's got the PCAP. It's now writing a to-do list, so the skill tells it to prepare a workspace, extract the data, then launches parallel correlation agents. It's found the infected host. Just note how fast this is compared to a human analyst going through a PCAP, copying, pasting, or typing out commands. It's just not comparable. It's just read 5 files. We'll see it slow down a bit here. I've got a fairly in-depth mapping of how I like to conduct PCAP analysis. I'm probably hand-holding the AI too much. This was done a year ago. I think the modern AIs like Opus, would probably be able to, orchestrate this themselves fairly effectively. I'm worried with how long it's, there we go. So it's launched 5 in parallel agents, and now it's going to do its own self-run investigation alongside that. So you see a ton of different bash commands going off. It's got a bunch of information. The C2, username, desktop name. It doesn't have, what should it say it's missing? The MAC address, which it should be able to find. Looks like it's got it already. Trying to quickly scan the T-Shark commands it's running. It still wants the username. I thought we got the username. Oh, it's got a username, BROLF, but it wants a full username. I'm not sure, or a fully qualified name, I guess is what it's looking for. It's looking at the C2 stream to see what information it can pull out. It's encrypted. I don't think it will find anything. Still wants the full username. Checking HTTP and SMB sessions. It's cheating now. It's going to the answer page. I'm going to have to interrupt it. No cheating and looking at the answer page. Do this at the end to do a gap analysis of what you could not find. So note, we're just watching the independent investigation. My preset investigation steps are still going in the background. You can see there's 2 jobs running in the background here on the bottom right. You can't see that because I've got a silly image. There you go. 2 jobs running here. It got the full name, Becca, ROLF. How did it do that? Decode SMAR specifically. PCAP. I don't even know what SAMR is. We're going to go Google on the other page. Yeah, I think the AIs are smarter than us. I'm still waiting for the Wave 1 agents to complete. There's 1 left. We can do a check-in on that. Jobs. Object Exporter is still running. Why would object exporting take over 4 minutes unless it's a huge number of objects? We'll give it a minute. There we go. SAMR, by the way, is Security Account Manager Remote Protocol. I didn't know what that is. Active Directory Enumeration or User Information Queries over SMB named pipes. God, in cybersecurity, you can never learn everything. It's just... So now we're going to watch the AI, do some further analysis. It's going to map the what happened to MITRE and things like this. This is probably a bit overkill for an orchestrated investigation, but, while this is working, I'm going to bring up and find... Not my videos. I actually don't know where it put the workspace. We'll wait for it to finish then. It just seems so smart. It sets off sub-agents and then it's like, all right, let's start creating the report structure while we wait for that information to come back. So wave 2 is more about reading all the findings. It does some additional lookups itself. but it's more about cross-referencing and building a timeline to put into the final report and some OSINT investigations. So you can see it here. It's because we're looking at a timeline. It's going to do C2 beaconing kind of investigations, and as I talked about, the MITRE mapping. But we need to do all of these in a separate wave from the first wave. This is consuming a bit more tokens than I thought. I am, 14% through my context. I might, rather than just sit here waiting, I'm going to have to cut this out to ask an aside question. The ask tool. Okay. By the way, that's the tool I want. So I'm asking an assigned question. I'm not sure that worked. No text returned. Okay. Well, it got there eventually. So we can start to see what it's populating while it finishes up. Original PCAP, extracted objects. This is why it took 3 minutes to run. There's a huge amount of them. HTM ones are probably not interesting. Some of the other ones might be. You'll notice it'll create a list of hashes for all the files that will run against open source threat intelligence. It'll collate that into IOCs. So for instance, we've got malicious IPs, only one. Malicious domains. These aren't malicious domains, these are just domain hashes. Interesting, it's broken this up into, these aren't file hashes though, right? These are hashes of other things. Now it does say file hashes. I'll have to check that. If you open up the analysis, you'll see a huge amount. It will record all the queries it ran. It makes different timelines, HTTP timeline, looks at specific files, output of its hash analysis, which we can, delve into. You can also see the output of each individual rate agent from the first 2 waves that was run. The timeline one might be interesting. Yes, this is its conclusion about the phases, network initiation, C2 establishment, beaconing. It mentions some of the background legitimate traffic. So far it's saying there's no, it can't see when the RAT was installed. I bet you that's not correct. I'm actually it'll be interesting, the gap analysis, once it finished the report. If it missed anything, we'll have to ask it to improve our steps. And this is the future of security work. Rather than doing anything yourself, you just monitor an AI agent to make sure it's not making dumb mistakes that a human wouldn't make. I don't know what the reconnaissance markdown is. Seems more like a, traffic analysis than reconnaissance. Now it's doing the gap analysis by itself. It's written a report. And it's going to do the gap analysis. NetSupport RAT, date, instant overview. At this time, this desktop logged in as domain user, the ROF, owned by Becca. This company initiated command and control communication with a RAT. So it's going to claim the RAT was already installed. It used plain HTTP on 443, but without using TLS. It's interesting. I'm not sure why a RAT would ever do that. You would think you would want the C2 to be encrypted. 67 beaconing. This seems like a poorly configured RAT. This is a type of thing I know we have alerts in our SOC that would capture. Yeah, initial infection vector is not captured. I'm going to jump back over to the gap analysis. All the core questions it got correctly. That's interesting. It's claiming the original doc has typos. Maybe at some point they typed 21 instead of 28. So this is it. AI is complete. Total usage, less than $5 of tokens if you're using an API. We have a full report. I guess some of you may not like the Vim look of things. Let's see if we can open it in something else. All right, we're cutting all of this out, guys. Open the final report in VS Codium. Don't worry, it'll be cut out. Practical analysis, network analysis. Timeline is often the best. The timeline's the best feature of this, to be honest. Beacon statusing every 6 seconds. IOCs, just one IP and one URL. It's made some Sigma rules to catch this, not really too relevant. I wouldn't ever use these in reality. Cool. We'll do a little bit of betting for ourselves, see if there's actually anything that was missed. This is where we're going to struggle to open it. The AI didn't check here for the answers. PDF file with the answers. Yes, give me the PDF. IP address, that's just the environment, background, victim details, 88. Desktop. This has done the full qualified domain name, arguably better. Full name of the user. That's something that took the AI a bit long to find, but it did get it. Malicious IP, it definitely got. MAC address we got. Name we got. That was it. I'd argue the AI pulled more information. Some of it's not too relevant. 60-second polling time and protocol details. Not too relevant unless you're in an ultra secure environment and you're going to build a custom rule to try and catch this. In most cases, you're just focused on the instant response and knowing which machines need to be rolled up. But yeah, really good. But yeah, again, the entire exercise was done just by me asking the AI to do it. I have to have some knowledge to kind of understand what the AI output is saying, and that makes sense. But yeah, as an analyst, this is what I'll be doing going forward. But anyway, gentlemen, catch you guys in the next one, if there is a next one. Maybe the next one will be more about setting up an AI to do this. Take care all.